What is a purpose of a Tesla coil? Few people think Tesla coil is a fancy instrument, but only truth seekers know that a Tesla coil is a device invented by Tesla in order to create longitudinal electromagnetic waves. Okay, so for beginners, there are two types of waves in nature, in any system, which is transverse transverse waves and longitudinal waves. Transverse waves are the waves similar to wave created when you drop a stone in a pond of water. Longitudinal waves are the waves similar to the wave created by sounds in air. Everybody is familiar with these two concepts. But for some reason, we are taught that the electromagnetic waves are always transverse in nature, and they have the electric field and the magnetic field varying perpendicular to each other, also perpendicular to the direction of propagation. But believe it or not, Tesla found that it is also possible to have longitudinal electromagnetic waves in nature, and for some reason it's not called electromagnetic, it's called longitudinal magnetodielectric waves, or simply scalar waves, because in longitudinal component you do not have a B field or a magnetic field. Everything is purely electrical, and one amazing thing is it looks like it's an electric field between two plates of a capacitor, which is what a magnetodielectric wave is. Now let's see if you want to how these two waves are created. For example, take transverse electromagnetic waves. Transverse electromagnetic waves can be easily created by well-known system. You take a coil and you give an oscillating current to it. It produces transverse electromagnetic waves all along the surface, all along the lateral surface of the coil, and you can receive it using a simple dipole antenna, which is like this, and you can actually hear some sounds over here, and this is your receiver circuit. This is what a conventional well-known transverse wave transmitter receiver system is. Now going to the second component, which is the longitudinal magnetodielectric or scalar waves, how it is produced and how does it works. Okay, believe it or not, these waves are the waves created by a capacitor. Yes, it is created by a capacitor. Now look at this diagram. What you have here is a battery connected to a capacitor. Once you close the switch, there will be a current going in, and there will be a displacement current going between these two plates. And according to C.P. Steinmetz, the very famous and unnoticed electrical engineering and also a scientist, it's actually scalar waves being transmitted between one plate and the other plate of the capacitor. And this is what the longitudinal component is. Okay, the displacement current is a misunderstood concept. So if you assume that it is a scalar wave, let's see how a Tesla coil is producing this in huge amounts. Now I am showing you a conventional diagram of well-known Tesla coil circuit. What you have over here is your main, and you have a high voltage transformer, in this case neon sign transformer. You step it up to several tens of kilovolts, and then you have what you have is a spark gap, you have a capacitor, and you have L1, L2. Everything is what you know already. But my question is, where is the longitudinal magnetodielectric wave created? Or in other words, where is the scalar wave created? Some people really think it's been created in the spark gap. Some people really think it's been created in the the coils. Some people, most people think it's been created by the L2 coil, which is this. And believe it or not, it's not the L2 coil, because what is created in the L2 coil is the conventional transverse wave, which is created all along the lateral surface of the coil, L2 coil, and it is transverse in nature, and there is nothing different about it. In a Tesla coil, in L2, you have a huge voltage being created if it is well tuned, about 30,000 to 1 million volts, which is quite large. Now where is the scalar waves generated? Which part? The answer is, it is being created in the torus, or the metallic object which you place at the top of the L2 coil and the earth. Yes, if you don't understand what I'm saying, I'll show you this diagram. Yes, what you see here is actually L2 coil, and you connect a metallic object at the top of the L2 coil, which I call it here as torus, and you have earth. So what you have here is a simple capacitor system, which is shown like here, where one plate of the capacitor is your torus and the other plate of the capacitor is the entire earth. and the dielectric inside is the air present around the Tesla coil. And this is an asymmetrical capacitor. The reason is one plate is the torus, which has a finite length, and the other plate is your entire earth, which is extremely large. So it's a asymmetrical capacitor, and it's basically a capacitor. Okay, so what you create here is an electric field of high voltage and high frequency electric field. That's what you create between the torus and the earth, and that's what is your scalar waves. You see, these variations in the electric field, they propagate in space throughout the earth. That's how you transfer power and all those things. Okay, now coming back to wireless power and how it works. You have a transmitter Tesla coil at point A on earth, and let's say you have receiver coils at point B and C of earth. Well, when you create oscillating electric fields of high voltage and high frequency, it's received in B and C. The electricity is received at B and C, and this circuit is very unfamiliar to us. And I can, for beginners, I can tell that it acts like as though this torus and this torus are connected through a wire. This torus and this torus are connected through a wire. Now, converting it into its electrical equivalent, this is the electrical equivalent of a Tesla wireless transmission system, according to me. So what you have here is a capacitor plate 1, and the other plate 2 is extremely large, okay, compared to the plate 1, and you apply a high voltage, high frequency oscillating voltage across these two plates, and you are using another plate over the left and the right side, and at this point and this point, and you are using the common plate which we used in the first transmitter for the receivers also, and you are trying to take the output at these 2 points across these 2 plates, and somehow we are getting the output. And the system acts like as though this plate, the smaller plate over here, the center, and the smaller plates on the left and the right hand side are being connected by a wire, but they are not connected by a wire, but it looks like they are connected by a wire. And that's how Tesla was able to transmit power using earth as a conductor. And that's it.